Thank you so much for watching this online video tutorial. Like, comment, and share, as well as subscribe to our channel at Good Better Best Online Videos for more video content. And where everybody should be in the syllabus though is obviously electricity, which is obviously circuits now. So quite a majority of the class is obviously started on circuits, which is great, which is fantastic. So what we're going to do is we're going to go back to doing a past paper question of it, because I've taught all the theory, nothing more I need to teach. So I pulled up the question 12 of 2018 grade 11 common paper. It is a November paper. Okay, and what we can do is just do up until question 12.5. Okay, so it says consider the circuit diagram below. The internal resistance of the battery and resistance in the wires can be ignored. 12.1 says calculate the value of resistor R, okay, if the total resistance of the circuit is 4,8 ohms. Now guys, that is very simple. That's a gift, okay, that is a gift. Okay, all you have to do is calculate what is the value of R. It is a gift. Okay, please don't mess this one up. It's very basic. 12.2, calculate the reading on the voltmeter if the current going through the 4R resistor is 1,8 amps. Okay, calculate the energy converted in resistor 4R in 2 minutes. So that's a power formula. And then this says 4R resistor is replaced with an ammeter. Okay. Now this says how will the reading on the voltmeter be influenced? Write down only increase, decrease, or stay the same. And then 12.5, explain your answer. So we've got 8, 11, 12, 13, 14. So that's about 15 minutes to do this paper, or this question until 12.5. I think that's the last question anyway. So 15 minutes to finish the entire question 12. And then we will mark and have a look at it and go through it one question at a time. Alright guys, let's give this question a bit of a mark. Okay, pull this one up. Right, this is 12.1, the electricity question. Doesn't help that I don't remember what the question was. Calculate the value of resistor R if the total resistance of the circuit is 4,8 ohms. Okay, so something here is that they've said that RT is equal to 4,8 ohms. Okay, now what they've done is that they've given us, of course, if I can go back here, they've given us different values obviously in R. Okay, so what we can see is that we've got 3R in a circuit here, 3R, 2R are in a circuit, but 4R and 2R are of course in parallel with each other. Okay, we can clearly see that. Okay, so it looks like we may have a parallel combination here that we're gonna have to work out first. Okay, so I wonder if we're gonna have an R square, because I think we only got 2 in parallel. I don't think these would count as parallel with each other by judging by looking at the circuit itself. Okay, let's just process this and think about this quickly before I ask anybody to maybe share the answer to it. Let's probably just think about it quickly, because it only looks like 4R and 2R are in parallel with each other, and not R and 3R, just by the looks of it. But then again, I could be wrong. I could be wrong, but you know what? I'm gonna go for it. Okay, cool. So in my mind, this is what I got. RT is 4,8, right? Okay. So what I'm going to do is I'm going to make the assumption that 4R is in parallel with 2R and 3R is in parallel with R. Okay, because they're both opposite each other, both parallel to each other. Okay, 2 sets of parallels. So what I'm going to say is R parallel is equal to, or the total resistance is a product of those 2 parallel circuits. So I'm going to say R parallel is equal to R1, R2 over R1 plus R2. Okay, so over here I'm going to say 4,8 for the value of R parallel is equal to 4R. Now if I look at the circuit again, 4R, and I got 3, 4, 5, 6. So in actual fact, it looks like all of 4R is in parallel, because judging by where it is situated, this is not above this line, this is not above this line. So it looks like that these three, 1, 2, 3, are all in series. So 4R is in parallel to all of these, making the value of the bottom one 6R. And then the bottom one would be, of course, or the numerator here, R1, 4R plus, sorry, not multiplied, plus 6R. Let me explain that again, because I know that is a question. I can feel it in my bones. This 4R is in parallel to all three of these resistors. Let me explain why. Because, judging by where it is situated, all three of them are at the bottom. Okay? All three of them are below this little line here, depending on where it is positioned. Okay? So everything below this is in parallel to this one resistor here. Okay, so 3R plus 2R is 5R, plus 1R is 6R, hence they're all 6. It's 4 times 6 over 4 plus 6. Okay, if you do that, we should be able to solve. So that is 10R, so that's 24R squared, 4,8. all over 10R. Okay, so 4,8 times 10R is going to be, I think, 48R is equal to 24R squared. And 48 divided by 24, 48 divided by 24, let me just check if I got this right. So then I get divided by 24, so then I get 2R is equal to R squared, and then obviously you could divide both sides by R. Okay, and that's obviously 1R, and therefore the value of R is equal to 2 ohms. Because these three at the bottom here are in series, that means we can add them up straight away. Maybe a simpler way to explain it. Because R, 2R, and 3R are all in series, if we add them up, we'll get 6R, right? So we'll get 6R at the bottom here, which is all parallel to the 4R. Hence why our numbers are not just 4R and 2R, but 4R and 6R, if that makes sense, because we can add all of these up in series. And then this one comes in across, parallel to all three. Now 12.2 says calculate the reading on the ammeter, on the voltmeter, sorry, if the current going through the 4R resistor is 1,8 amps. Okay. Well, there's multiple options for calculating this one. Okay. There's multiple options or multiple ways that we can calculate this one. I think there's about 4 options. Okay, but I think I'm going to choose the one that's a bit most obvious. Okay. So if we come over here and we decide to use the formula that the voltmeter reading across the 4R resistor must be equal to I times R, the resistance of the 4R resistor. Notice I'm being very specific. Now the voltmeter, remember, is across the 2R resistor, which is also one of the resistors that's in parallel to the 4. So the voltmeter reading will be the same across both. Okay? Or at least it should be. Okay? But they want the voltmeter reading now. Okay. So, the voltmeter, or the voltmeter reading going across the 4R resistor would have to be equal to the current that's going through the 4R resistor multiplied by whatever the value of the 4R resistor is. Now remember, R is equal to 2, and this is 4R, so 4R's value will be 4 times 2. And on my calculator quickly, 1,8 times 1,8 times 8 is 14,4 volts. Okay? 14,4 volts. Okay. Now we want to find out what's the current that's going through the rest of the resistors. Okay, because 1.8 amps is going through the 4R, then obviously you know in a parallel circuit, current splits. So what's the current going through the 6R resistor? Or resistors? The total of the 6Rs, the 3 resistors in series. Okay, so that's going to be your voltmeter reading, V divided by R. Okay, R of 6R. Now 6R is equal to, of course, 6 times 2. The value of that's going to be obviously be 12 ohms. So the voltmeter reading is again the same, 14,4 multiplied, of course, or divided, sorry, not multiplied, divided by 12. And that'll give you 1,2 amps. Okay, let me take these calculations away. So they were just side calculations. We didn't need them for the question. Alright, cool. Now, the voltmeter reading going through across the 2R resistor is equal to just I times R. We know the current that will be passing through it should be 1,2. And 2R, we know the value of that resistor is, of course, 4. Because R is 2, and 2R, 2 times 2, 4 ohms. So 1,2 times by 4. Therefore, the voltmeter reading going across the 2R resistor, which in this case is the 4 ohm resistor, is 4,8 volts. Okay, let's remind ourselves of that question one more time. Calculate the reading on the voltmeter if the current going through the 4R resistor is 1,8 amps. Right, so that means the current that went through 1,8 amps here, 1,2 went through 3R, 2R, and R, and then met up again here. Okay. Let's look at another method that makes about, I would say, about equal sense, about equal amount of work as well. Is we can work now with the totals. So again, you're still gonna have to use the first part though, which is the voltmeter reading going. What's the number of volts going through the 4R resistor? So that's again I times R of the 4R resistor. That's 1,8 multiplied by 4 times 2, and then that's going to equal 14,4 volts. Okay, so we still need to do that first. Now that we've got that, let's work with totals quickly. The total current, what is that? That must be equal to the voltmeter reading, okay, divided, or the total volts rather, divided by the total resistance. So we got I is equal to 14,4 divided by 4,8. That's equal to 3 amps. Okay. Now that we've got the total current that's in the circuit, the current that's going through the 2R resistor now, let's focus on that. Well, if 1.8 is going through the 4R branch, then whatever is left must be going through the 3R, 2R, and 1R. If 1.8 is going through this branch, then the other bit, which is 1.2 amps, must be coming through this other branch over here. Okay. So the current going through there is 3 minus 1,8, of course. We calculate that to be 1,2 amps. Okay. Just go a little over here. 1,2 amp. Okay. Now we use the same formula. V is equal to I times R, which is now equal to 1,2 multiplied by 4, which is still given at 4,8 volts. Is the voltmeter reading across the 2R resistor. Where do we get the 4 from? Remember, this is the V2R, and the value for R is equal to 2 ohms. So we just substitute 2 for R to get what our resistance value is or was. 12.3, calculate the energy converted in resistor 4R in 2 minutes. Okay, this is a power formula. Okay, I'll bring this back here quickly. Leave it like that. It's a power formula. So we've got also multiple options here though. So one thing, we know the current going through the 4R resistor. So I 4R is equal to 1,8 amps. We also know the value of 4R is equal to 4 times by 2, which is equal to 8 ohms. Okay. We also know the time, delta t, is in 2 minutes, which is 120 seconds. We also know the voltage going through the 4R resistor. Going through it is about 14.4 volts. So we know that as well, if you want to use that as an option. Okay, so we've got multiple options here. Okay, let's just cordon this off quickly. And I'm going to use one power formula. And then I'll use another two as well. Or maybe just another one, depending on how I feel. Okay, so the first one is the energy dissipated. W is equal to I squared R delta T. Is I wouldn't say a power formula, but it's a energy formula, of course, which does fit in or tie in with power. So the energy dissipated, let me just make sure it is that question. Energy dissipated, energy converted, same thing, different flavor. Okay, so that is equal to, of course, 1,8 all squared, which we calculated previously, multiplied by, of course, 8, value of the resistance, multiplied by, of course, 120. It will get about roughly 10,000, no, not 10,000, 1,036, sorry, 8 joules. Okay, if you use this way. Okay. However, if you use the other ways, you are going to get different answers, but I think the other ways will probably give you answers around the same. Okay, I've got 2 yellow colors now. Wow, that's awesome. The second one is using W is equal to VI delta T. Okay, so now if we use this one, 14,4, which is the voltage, times the current, which is 1,8 times 120. If I put that on my calculator, times by 120, we get a slightly different answer. Now, why it is accepted, I'm not sure. Okay, we get now an answer which is obviously way bigger than this. Okay, which is 3,110,4. Okay, I must test the other option as well again. 1,8 all squared multiplied by 8 multiplied by 120. Okay. Oh, sorry, that's why we got a different answer there. When I did the calculation, I actually forgot to square the 1,8. So I'm so sorry. Please forgive me. Made a very silly mistake there. This is also 3,110,4. 3,110,4 joules. This is method as well. And then, of course, there's this method as well, which gives you the same answer. I just forgot to square my 1,8. Very, very fatal mistake. Otherwise, I would have gotten a totally different answer. All right. The third option, of course, or formula is W is equal to V squared delta T all divided by R, which is 14,4 all squared times 120 all over 8. Okay. If you do this, you'll still get the same answer. Okay, I'm going to double check it as well, since that I made an error there that almost costed everybody their marks. So sorry. Yes, it is the same answer as these two, which is 3,110,4 joules. Okay, that's 12.3 all done. 12.4 asked now that said that the 4R resistor is replaced with an ammeter. Calculate the sorry, not calculate, but if we had the question that could have been there was calculate the new total resistance, but I mean they ask how will the voltmeter reading be influenced. Write down only, increase, decrease, or stay the same. The answer there would be decrease for 12.4. The reason why it would decrease, the voltmeter reading would decrease. If you look where the voltmeter is and you place an ammeter there. Okay, first of all, the 4R resistor, you take that away. Okay, you've only got 6R, and 6 times 2 is 12. So the resistance has increased a bit, slightly, because then you only have a series circuit. Okay, and you only have a series circuit, although the total resistors, they said the total resistance of the circle is 4,8, so the resistance increases a little bit. But the voltmeter decreases, and if I explain my answer, is the ammeter, of course, has a low resistance, and it short circuits the parallel part as all the current flows through the ammeter. Okay, because the ammeter must be connected in series and not in parallel. If you connect the ammeter in parallel, you'll have a short circuit. Okay, so the ammeter short circuits the resistors and no current flows through the 2 ohm resistor. Okay, that's possibly a very nice way to state this one for 12.5, because it decreases. Okay, the ammeter short circuits the resistors. Okay, so therefore no current flows to the 2R resistor, because there's a short circuit now. Okay, short circuit's not a good thing. And that wraps up question 12, because the voltmeter reading therefore decreases. And that wraps up our lesson for this evening on revision of stoichiometry, as well as looking at another circuit question again. Please don't forget to like this video, as well as comment, as well as subscribe to our channel, Good, Better, Best Online. And we will see you all in the next video with some more physics goodness.